In this video, we look at the fundamental counting principle. The fundamental counting principle is a way that helps us count things a little bit more efficiently. So one of the sort of technical definition of the fundamental counting principle is that when we count objects, if there are m ways to do one thing and n ways to do a second, then there are m times n ways to do them together. The key word here is and, so we want to be able to do both of those things. It is a bit wordy. We'll look at an example to see what that looks like. So here's the example that we'll look at. We'll look at 4-digit pins. So a 4-digit pin is a number, consists of 4 digits. We need to have a first digit, a second digit, a third digit, and, there's that keyword again, and a fourth digit. So we need each of these. So let's look at the possibilities. For each digit here, there are 10 different options. So for the first digit, we can have the numbers from 0 to 9. So 0 all the way to 9. That's 10 digits. 1 to 9 is 9, plus the 0 gives us 10. The second digit could be 10 different possibilities. The third could be 10 possibilities. And the last can be 10 possibilities. We want to have a first digit and a second digit and a third digit and a fourth digit. So the total number of ways to have a pin that's 4 digits in length is to have 10 times 10 times 10 times 10 possibilities. We can write that as 10 to the 4, which is also equal to 10,000. And if you think about that for a minute, it kind of makes sense. We could start a pin at 0, 0, 0, 0 and increase by 1 every time, and we would stop at 9, 9, 9, 9. So from 1 to 9,999 would be 9,999 possibilities. Add in this 0, 0, 0, 0 as a possibility, and you get 10,000 possibilities. The other way that we can count is with a tree diagram. You've probably studied tree diagrams in elementary school. Let's have a look at how they relate to the fundamental counting principle. So we'll look at some mittens. You have 3 choices for mittens. Your mittens can be red, blue, or yellow. So red, blue, or yellow for color. And then you either have a choice of a string or no string. So we'll just kind of add that in here, string, no string, and I'll just abbreviate S and NS for these options down here. So there's a tree diagram. It shows all of the possibilities. Some of you might write your tree diagram in this fashion instead. Red, blue, and yellow. And then your string or no string down here. It doesn't matter, doesn't matter which way you do it. Whatever your personal preference is, and you can go from there. Now, when we do a tree diagram, we can see that here's a possibility. So red with a string, or we have another possibility here, red with no string. We can go through the entire list and count up how many possibilities there are. It turns out that the number of possibilities is equal to the number of branches in our tree diagram. Here's one branch, here's another, 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 and another. So in total, 6 branches, so there are 6 possibilities for mittens here. Question here says, how does the diagram illustrate the fundamental counting principle? Well, there were three choices here for the color, and for each of those 3 choices, there were 2 choices for the string, either a string or no string. 3 choices for color, 2 choices for string. We need to have a color and either string or no string. So there were 6 possibilities there. So that shows you how the tree diagram is related to the fundamental counting principle. Now the tree diagram gets cumbersome for large sets, so we use the fundamental counting principle, but you can certainly start with the tree diagram until you get the hang of the fundamental counting principle. So that's a fairly quick summary of the fundamental counting principle.
Let's look now at the additive counting principle. What the additive counting principle says is that if you can choose m items of one type or n items of another type, and that keyword or is really important, the total number of ways to make a choice is m plus n. So really what that's saying is that if you have 2 choices to make and you're choosing one or the other, that's when we would add them together. Let's have a look at an example. So we've already done an example with pins. So let's we may as well stick with that. So here's the example. The question is asking how many 3 or 4 digit pins can there be? We've already figured out how many 4-digit pins there can be. So let's do the same sort of thing with 3-digit pins. Again, the 3-digit pin has 10 choices for the first digit, 10 choices for the second digit, and 10 choices for the third digit. So we need all 3 digits to make a 3-digit pin. So it's the first one and the second and the third. So that means we need to multiply those together. And when we do that, we get 1,000. Now we could probably figure out without the additive principle, the additive counting principle, pardon me, if you have 10,000 4-digit pins and 1,000 3-digit pins, the number of ways that you have 3 or 4-digit pins is just the sum of those two. And that's really what the additive principle is. So we can add those together. 10,000 plus 1,000 equals 11,000. Forgot a 1. So therefore, there are 11,000 3 or 4-digit pins. So really important difference between the fundamental counting principle and the additive counting principle. The key difference is that the fundamental counting principle is when you have one thing and another, in which case you multiply. The additive counting principle is when you have one thing or another thing, in which case you add those things together.